This is how to solve a rational inequality like x plus 6 over x minus 2 is less than or equal to 3. First of all, you need one fraction, and we need an inequality with a 0 on one side, so I'm going to bring the 3 over. And then again, I need one fraction, so now I'm going to get a common denominator. I'm using the what's missing method. I'm missing my x minus 2 over on the right-hand part. So I'll put it in the numerator and denominator. Draw one fraction bar, I get x minus 2. In the denominator, in the numerator, I get x plus 6 minus 3x plus 6 is less than or equal to 0. Simplifying the numerator, I get negative 2x plus 12 over x minus 2. Whoops, I put 16 instead of 12. That's a 12 there. Is less than or equal to 0. And now I'm going to find the zeros of the numerator and denominator. So I set negative 2x plus 12 equal to 0 and solve. And I get x equals 6. And then in the denominator, that's a little easier to see. X minus 2 equals 0 when x equals 2. So now I make my sign chart just like we did with the other problems, with the factoring problems, and I test numbers. I'm testing it back into this inequality right here. So for example, if I test 0, because 0's in this area right down here to the left of 2, I get a positive 12 in the numerator when I put 0 in, and I get a negative 2 in the denominator, which gives me negative 6, and I'm trying to see, is that number less than or equal to 0? And that's a yes area. Now I pick a number between 2 and 6, like 4. I put it in the numerator, and if you put 4 into the numerator, you get 4 over, because it's negative 8 plus 12, over 2, which is 2. And I'm trying to see, is 2 less than or equal to 0? And the answer to that is no. Again, I'm using less than or equal to 0 because of this part of the problem right there. Okay, pick a number bigger than 6, like 7, and I get a negative 2 in the numerator because I have negative 14 plus 12. And if I put 7 in the denominator, I get 5. So that's a negative 2/5. Is a negative 2/5 less than or equal to 0? Yes, because it's negative. So my two areas are from negative infinity to 2 and from 6 to infinity. So now I just have to get the equal to's and the closed and open brackets. Because it's equal to, I can use a closed bracket, but I have to make sure not to use the number 2 because that makes the denominator equal to 0. So I'm going to put a squiggle here reminding me. So my answer to this question is negative infinity up to 2. Don't use 2. Or pick it up again at 6, and I can use 6 to infinity. Again, the closed bracket is because of the equal to.